before going to that, I would like to ask CIDT Hyderabad also, although you haven't shown any interest in this, but after just hearing out from our CSIR scientists, if you want to say anything, you may please offer your comment, and other participant, industry participants also. If you want to say anything, please, now floor is open for your comments. Industry participants from Hyderabad-based industries were invited by the CIDT Hyderabad. Okay, then if there is no specific comments, we will move to the next presentation from CSIR IIP, Gale Waste Plastics to Fuel and the Chemicals Technology. Dr. Ajay Kumar from CSIR IIP, please. You may please upload your presentation, sir.
Okay. Okay, good morning. Let me share my presentation.
Gas qualification caution.
Otherwise, if there is any comments, you may put in chat box also.
Yeah, our PPT is visible.
It's visible, sir. Please make it slideshow mode.
Now it is okay?
Yes, we can see.
Okay.
Please go ahead, sir.
Okay. First of all, good morning to all of you. First, let us introduce myself. I am Dr. Ajay Kumar. I'm working as a scientist here. And brief about our institute. Which we would like to highlight our technology that is called the CSIR IP Gale technology. This technology is for the producing fuels and chemicals from the waste plastics. So just I give some brief introduction about the plastic. As you know, the plastic has number of applications right from food packaging to electronics. To imagine life without plastic, as you know. So if the application is more generation of the plastic takes place, more consumption of the plastic, and more waste generations. So if we have more generations, and as you know, the plastic is non-biodegradable, so we have to have the solution how to dispose it, because it creates problems to our society, to our health, to human being, animals, everything for environment. So we have conventional waste management, like, as you know, landfilling, incineration, mechanical recycling. As you very well know, I am not going to detail all these things. And here, what IIP offered, chemical recycling. So what is the chemical recycling? As you know, the plastics is, the origin of plastic production is crude oil. So we want to recycle from plastic to the crude oil. It is the permanent solution. If you see the conventional like incineration, mechanical recycling, all these things, this will not give the permanent solution. So here our emphasis is to convert the plastic into the crude like pyro oil, and then convert into the useful products like petrol or diesel. So what types of products IIP offered from chemical recycling of waste plastic like petrol, diesel, greases, bags, chemicals. So what is the CSRIP GIL technology? So what types of feed required for this process? So all polyethylene and propylene, P and PPs, are useful for this process. We are avoiding PET bottles, PVC, all these plastic, because these polyethylene and propylene, almost 60 to 70% of the total MSW plastic. So we are here targeting only polyethylene and polypropylene. So, as you know that this MSW plastic contains the materials, foreign materials like organic contaminants. So we have to pre-treat these plastic. So this plastic can be useful for our process. So there are a number of steps for pre-treatment. Like firstly, we have to dust blowing. Then after the threading for the threading of the plastic into the smaller pieces. Then water washing, then drying, and then agglomeration. So these are the steps for pre-treatment of the our waste plastic, and this feed is useful for our the process. So what is the CSRIP GEL technology? GEL technology, if you take 1 kg of plastic, you will get either diesel along with the LPG.
Dr. Ajay, your voice is breaking. Dr.
All,
Ajay, Dr.
yeah.
Ajay, your voice is breaking in between. Is there a connectivity problem? Suddenly we don't hear anything from you. Yeah. Please continue. Please continue.
Not, now it is okay?
Yeah, now it is fine, but we are losing your thing. Yeah, now it is fine. Please continue this way only because there's a lot of break. And for a few seconds, we are not able to hear you at all. So please start. Continue. Dr. Ajay, please continue. Okay. Yeah.
Okay, just repeat for to scale. I am talking about the yield of our process. So if you take 1 kg of plastic, we will get diesel around 750 ml along with the LPG. If you want to produce the gasoline, we will get the 650 ml along with the LPG. We can also get the petrochemicals like benzene, toluene, xylene in this process. So what is the process? Just as discussed, firstly we have to pre-treat the waste plastic, whatever get from the MSW, from municipality or MSW, from any source. So we have to pre-treat it, and then we paralyze it, and followed by the catalytic reactor, and then fraction. Then we get the products like gasoline or diesel. So these are the steps how we have developed this process or technology. So initially we have lab scale, then after a scale up to the bench scale, then a scale up to the pilot plant, 1 TPD pilot plant, which is situated in the IIP Dehradun. So we are working on, we are optimizing the process, working on that for the data generation on 1 TPD pilot plant at present. So this plant is inaugurated by our Honorable Minister, and on 27th August 2019, and we are working on that. We are taking the run feed cut on this 1 TPD plant and for the data generation. So these are the some property. As you know, if you say the diesel or petrol, we have to meet the BS4 or BS6 standard norms in terms of density, viscosity, final boiling point, aromatic content, all these things. So these are the properties. So in our process, these properties are meeting. This is for the diesel. So these properties are meeting the diesel from the waste plastics. So also we did some emission performance of these waste plastic fuels. So we have the laboratory in IIP. So we have to check in terms of emissions like particle, carbon dioxide, all these things. So it is matching with the conventional diesel which are obtained from the petrol pump. This is the just efficiency of the fuel in terms of kilometer per liter. So it is the as par with the conventional diesels, which are obtained from the petrol pump. Also, we have developed the technology from the base plastic to wax and greases. As you know that the economics, if you think in terms of economics, so we cannot increase the price of the diesel or petrol because it due to the social cause or something like that. And so we have developed also to produce the petroleum waxes or greases which are costlier than the diesel or petrol. So it is their economics is good compared to the better compared to the petrol or diesels. So we have also developed this technology. So in terms of the utility requirement, manpower requirement, or all these things, so we have land requirement, all these things. So I mentioned that we have to have the pretreatment unit as well as the process unit. So land for the pretreatment unit, land requirement is 2 acres. For a conversion unit, diesel conversion is 1 acre. Electrical power, also we need water, all these things. LPG for the starting fuels. So last, we have to conclude that this is the process to produce the diesel and petrol and solve the waste plastic disposal in an environment-friendly manner. CSIR IP also developed the wax for the waxes and greases from the waste plastic. These plants can be in a hub and spoke model, means the pretreatment unit at the site of the, you can say, municipality or where the plastics are concentrated, and process unit is far away from that. And this process is economical if we set up the plant for the lower capacity like 1 TPD, 2 TPD, something like that. So this is the existing facilities. As you are seeing the 1 TPD plant. Also, we have glass reactor, lab scale reactor, bench scale system in our IIP campus. So these are the teams who are working day and night for generating the data. So thank you all. This is.
Thank you, Dr. Ajay. PPDC Agra, any comments? Or any of your partners, if they want to say anything?
Thank you, ma'am. Thank you, Dr. Ajay. Just one question. I think in the document that we have received regarding the this idea, the capex investment is around 70 crores. Is it so? And the operational expenses mentioned here is on the document is 11 crores.
Yeah. This is for 1 TPD, 10 TPD plant.
Okay. So this is about 10
ton per day plant.
Okay, thank you.
This plant is like this. If you come to IIP, if you want to like to see the plants, it is like refinery because we are producing the automotive grade fuel like diesel and petrol. So it is like refinery. So there is lots of equipments are there. We have to keep the safety, all these things. If we have to have set up the plants. It is not like the conventional, maybe you are seeing some from China plant, all these things. It is not like that. So you are welcome to visit IIP, Dehradun, to see the plants and just to get the feeling of the plants like that.
Sure, sir. Thank you. But considering the capex and the operational cost, I think this is difficult for the MSMEs to market and implement at their end.
Yeah,
but surely
so
we will discuss with you visit the Dehradun plant. Thank you.
yeah, so PPDC Agra, we can facilitate that visit of your, of your team as well as the MSMEs with you. If some of them want to visit Dehradun and see the plant for themselves, right? So that can be facilitated.
Okay, ma'am. Okay, no problem.
Okay, thank
Yeah.
you, ma'am.
Yeah, thank you. So,
When we ask CIDT Hyderabad to offer any comments.
yeah, any comments from CIDT Hyderabad? CIDT Hyderabad, any comments from you?
Any of the industry participants? If there is no specific comments on this particular technology, shall we move to next one? That is EV kit for retrofitment of three-wheeler diesel autos in electric autos from the CSIR LIP. Dr. Ravindra, you can please upload the presentation.
Who's there then?
एक टीम है बट अलग अलग नाम पे पता नहीं चल रहा. Sir, are you there in the meeting?
Yeah, Mr. Gulshan Bish, anything from you?
Ma'am, good morning. Yes, it was a wonderful presentation by PPDC Agra and CIDT Hyderabad. And we have few MSMEs present amongst us. And I think Mr. Sahaj is there from T-Works. And Eeva Patent is there, I can see. And Dr. Pankaj is there. So if anybody has any comments, any questions, they can ask from T-Works. or
Yeah,
Eeva Patent.
any questions or anything else any comments you want to make on either the furnace technology or this waste plastic to diesel and other chemicals technology? You're most welcome. Yeah. So if none right now, can we go to the next one?
I'm with Dr. Lakshman from Hyderabad.
Yeah, please go ahead.
Regarding this waste plastic to fuels, for most of the SMEs, I think this will be kind of high-end technology. Is there any technology with IIT for converting waste plastic into a useful product?
Yeah,
Other
so
than-
there are. So Dr. Ajay, you'd like to take that call? Dr. Ajay,
Please repeat the question.
the question
Please
is, he
repeat the
says,
questions.
this seems to be a sophisticated technology, but is there any technology from IIP that, of using waste plastic to any other material? So you can take that question. Otherwise, I can answer for the others. Yeah. Dr. Ajay?
Yeah, actually, yeah. I understood the questions like that. Because as you know, this is a very, as you said, the sophisticated technology. So as right from the beginning, the plastic is highly flammable, and their products like diesel and petrol is also very highly flammable. Like refinery products, refinery produce the diesel or petrol or LPG, all these things. They are highly flammable. So safety and rest should be, as a government organization, safety is first priority. And also, that if your application is plastic, if you have there is a cold temperature, yeah, there is a temperature in drop in temperature, the plastic will condense, solidified, and there is a huge pressure drop in some place. So we have highly flammable diesel and petrol. So in this term, we have sophisticated equipments, instrumentation for safety point of view. That's why cost inclusive. We don't just to heat up, vaporize it, condense, who get the products like a pyro oil. And as you know, the pyro oil, it emits the lots of emissions like this. So our system is like very eco-friendly systems and generate the automotive grade fuels. That's why we have sophisticated and capex wise increase. That's I want to tell like regarding this.
Dr. Ajay, I think,
yeah.
So he's already got that answer, and his comment is that this is a sophisticated technology. He wanted to know if there is something else available. Now, Dr. Vadan Rao, there are technologies available with CSIR, other CSIR labs like NPL, that's National Physical Laboratory in Delhi. They had developed, tiles out of waste plastic, and there are also paver blocks developed by CMERI Durgapur using waste plastic. Okay, these are the very, very simple technologies. Any plastic collector can use this, make use of this technology. And as PPDC Agra and also CIDT Hyderabad, they said that, for constructing one TPD plant, I think cluster of MSMEs can definitely, develop or even a 10 TPD plant. It is not that every individual MSME needs to develop that. And all of you, whosoever are the plastic collectors, you can use this plant and, you can use this technology to develop diesel or any other chemical of your choice. So one plant and can give you many other products. So that is why it's useful for you to go visit Dehradun once, visit the lab, see the plant for yourself, and then take a decision on this. Right?
Sure. Thank you.
Yeah. Thank you. So if no other comment, can we go to the other technology?
Dr. Ravindra, are you there?
Yes, I'm. Good morning, madam.
Yeah, good morning. Yeah, please. You can start your presentation, Dr. Ravindra. So this is another technology of retrofitment of 3-watt diesel autos into electric autos using this EV kit. So Dr. Ravindra, it's over to you.
Okay, thank you, madam. Is it visible, the slide?
Yeah, it is visible. Please go to the slideshow mode.
Is it visible now, madam?
Yeah, it is. Please go ahead.
Okay, thank you. Thank you. Good morning, everyone. I'm Dr. Ravindra from CSIR IIP Dehradun. We have been working in this electric vehicle for last few years. So today we are going to present you a technology which can be used for new electric autos as well as for the existing diesel autos, so that it can be converted to electric autos. So it is a product for two purpose. Moving on. Just one slide just to give you a background of IIP. Our IIP is part of the CSIR. It was established in 1960. So our organization is 64 years old. And we have transferred many technologies to many refineries and other related industry across India as well as across the globe. So basically we are into the hydrocarbon sector, that is energy sector. Our main purpose is to save energy and to replace the petroleum product with the indigenous product, and some percentage of the petroleum product has to be replaced with the indigenously produced fuel like ethanol, so that our import energy bill is reduced. That is the ultimate target. And to reduce the fuel consumption, any other technologies that are available, we are working in that area, because ultimately the petroleum products are used in vehicle as well as for genset. So 70% of the total crude oil is used for transportation. So there is a huge petroleum consumption. That's why government is trying with different and alternative technology to reduce this import bill as well as the energy import. So moving on, we have different division, and the division where I belong is called Automotive Fuels and Lubricant Application Division, and we deal with the applied area where different fuels are tested for their performance and their compatibility with the material and so on and so forth. And you might have heard of the E20, E10 plus the upcoming the flex fuel. So there your petroleum product is not 100%. It has been mixed with the alternative fuel so that we reduce the petroleum product. And the introduction about our technologies, that there are thousands of diesel autos of L5 categories are already on road, and they are polluting noise as well as air pollution in the cities as well as the capital cities and the tier 1 and tier 2 cities, and which lead to the associated health issues because diesel autos are emitting high amount of PM10 and the 2.5. That's those emissions are very much harmful to our human health. So, and we have devised one device which is still under evaluation stage, and with such indigenous device we can convert the existing the diesel autos into electric auto, and which will mitigate the unhealthy level of air and noise pollution in the state capitals as well as tier 1 and tier 3 cities. And apart from that, this product will be the import substitution, and again it aligns with India's energy independence goal of Viksit Bharat as well as Atmanirbhar. Then again it will contribute to our target of 30% electric vehicle on road by 2030. And at the same time, this kit can be used for any other new electric autos which can be designed and developed by different entities. So this kit will be common for two purposes. One is for new three-wheelers, and one is for the electrification of the existing diesel autos into electric vehicle. So these are all part of the government policies, because we have the Supreme Court restriction of using the older vehicles on road, the 10 years for the diesel and 15 years for the petrol. So at the same time, we have the scrapping policy nationwide, and the scrap vehicles are finding place to be stored, because in metro cities we have a very high cost of real estate. So we cannot accumulate these all vehicles without having a proper mechanism to scrapping. Otherwise, a lot of vehicles are piling up in the metropolitan cities, and people are finding to scrap it. So this is the problem. So at the same time, with this kit, we are extending the operational life of the diesel autos, and giving more earning time for the owners and the diesel auto operators. And our target is to have the L5 category vehicle, L5 passenger as well as cargo. And the cargo vehicles are used for last mile delivery by different commercial platforms like Amazon, and at the same time for new auto rickshaws. So just to understand the subsystem level, there is this diagram shows you how the subsystem are mounted inside a vehicle, and what are the major subsystems. Like we have the major part, electric motor, electric drive, there is a controller, battery, then DC-DC converter, then a vehicle electrical appliances. These are the major part of an electric vehicle. Then moving on, and then we need to have a thorough study for the EV motor selection. Depends on the vehicle category, whether it is going to be a cargo or passenger, because the weight and the other vehicle dynamics, it will be different. So the selection of EV motor is very important from the perspective of sustainability and the efficiency perspective. And from the sustainability perspective, the permanent magnet motors are not going to be sustainable because of the use of the rare earth material, and which are not much available in India. So at the end of the day, we may be importing the rare earth material, the magnets, from other country. Then will end up again to another problem. That's why here in our study we are using the non-rare earth electric motors, so that it will create a sustainable ecosystem for electric mobility. And while selecting and designing the electric motor, we need to see certain factors like frequent start-stop, high rate of acceleration, deceleration, depends on the different drivers' behavior. Then high torque, low speed, for example, like hill climbing or flyover climbing. There we call it the road gradient in the technical term. Then low torque cruising. These are all the part we need to consider. Then we need to see that very wide speed range of operation, so that we can have at least 50 km/h speed. Otherwise, unlike e-rickshaws, which has a regulatory limitation of 25 km/h, that causes traffic, traffic jam and all those undesired things on road. So that this electric autos are different from electric rickshaw because of the this load carrying capacity as well as the vehicle speed. Moving on, and the selection and sizing of battery is very important. depends on the how much electric mileage we are targeting to achieve. For example, 100 kilometer per hour or 100 kilometer, 150 or 80 kilometer, so on and so forth. Then we are using lithium-ion battery because of the high energetic density with a smaller size and many other advantages. And moving on, and while doing such engineering work, we need to also consider the different drivetrain topology, how your motor and the gearbox and the differential can be arranged and connected. There are different ways of connecting and arranging these products. This subsystem inside the vehicle. So these are the different topologies that I will be discussing briefly. The first topology, you can see the EM stands for the electric motor. Electric motor is directly connected to the clutch, gearbox, then differential. This is a typical drivetrain topology of an IC engine vehicle. So where IC engine is removed and then electric motor is fitted into that. And it's a very simple one. And the second one, we have the electric motor directly connected to a fixed gear. So this is what we have done in our one of the proof of concept study. And then third one, we have the electric motor directly connected to the differential. This topology is adopted by the electric rickshaws, e-rickshaws. If you look at the electric rickshaw, you will find the electric motor connected directly to the differential. So moving on, the fourth one, we are using two electric motor with a one common drive shaft. And then here presence of two electric motor will make more expensive, then will make the control algorithm very complex. So then the fifth one, we have two electric motor with individually and independently connected to its rear wheel, then through a reduction gear. So again, this is all for study and research purpose. Commercially and physically is not available. And the last one, again, we are using two hub electric motors. The wheel rim itself is the motor, like you have electric two-wheeler and the scooty. So these are the different topology based on our requirement and the techno-economical analysis. We need to select the appropriate the topology for our new kit as well as for our new electric vehicle. And moving on, and the last, how you transfer your electric motor torque to your wheel. So this is the mathematical equation and the science behind how you are transferring your electric motor torque to the wheel. So you can see here, it is a two-step gear system. Your electric motor torque is transferred to the wheel through two gear system having two gear ratio. One is the K0 first gear and the K1 is the second gear ratio. So then once you get the torque at the differential, which is divided into two equal torques on each wheel, then once you have the torque on the right wheel and the left wheel, then which will be again used for calculation of the force on the wheel. So this force is what you require to select and the size of your electric motor, because this force will be used for the propulsion of the vehicle, to move the vehicle forward and to carry the load. So that is how we calculate the forward force for its vehicle and the force acting on its wheel. Moving on, this is the research that we did a couple of years ago, just to check the feasibility of conversion of existing IC engine vehicle to electric vehicle. So this was done as per the gazetted notification CSIR 167E, and this legislation allows to convert any existing IC engine vehicle into electric vehicle, subjected to the approval and the certification of the kit. And then this conversion process will be done as per the automotive industry standard 123 part 3. So this is what we have done in our lab, and so we found that this is very much doable, and there are a lot of advantages of doing this from the techno-economical perspective. So moving on, and the part of that prior research work, we have done these experiments in the laboratory and on road. So once converted, then vehicle is subjected to the road load simulation on a chassis dynamometer and driving with the Indian driving cycles, and all the Indian driving cycles which are common in all the automotive industries like IDC and MIDC, modified Indian driving cycle. We have used that, and similarly we have used different equipment to check all the vehicle dynamics, safety, and stability. For example, like once you remove the IC engine and the related parts, your original vehicle dynamics is disturbed. So we need to bring back the center of gravity back to the original position. That's why we need to measure the new center of gravity and all so on and so forth. Then we need to determine the new parameters of the retrofitted as well as for the new vehicle, like the attractive force, and then vehicle reference weight, and then new center of gravity, so on and so forth. And then you see here the alpha is the road gradient. For example, alpha is 0, then it is running on the flat surface. So when you are climbing hill, either it has to be alpha, some angle has to be there. So as per the regulation, so the road gradient has to be tested on the 5, 7, 10, 12, 12 and the 20. So maximum 20 has to be tested. So these are all the science and engineering behind the retrofitment and the development of new vehicle. Moving on, and we have used the modified Indian driving cycle during the laboratory test. Then during the entire cycle, we collected and recorded the electrical parameters like current, voltage of the electric vehicle. Then we analyzed the area of improvement, then how much energy consumption, then what was the maximum current flow, and so on and so forth. Likewise, the same vehicle is put on real world test on road, on actual road. Then we see the energy consumption and all other electrical parameters, and then compare the laboratory data and the real world data. Then we'll find the gap, and then improvement can be done. So these are the standard driving cycle that we use in our laboratory. These standard driving cycles are used in all the automotive industries across the country. Then WLTC is the new cycle, and it is used worldwide, and now India is going to adopt this new driving cycle. And moving on, and this is very important part. Once we have the new vehicle or the retrofitted vehicle, it has to go through the regulatory compliance tests, and all the regulatory the methods defined under the automotive industry standard. It has to go through that. It has to pass. Then only the testing agencies will give the certification for launching and for commercialization purpose. So it is done under the CMVR homologation requirement, the Central Motor Vehicle the rules homologation. So there are so many the legislation and as well as the procedure that we need to follow for the new vehicle as well as for the retrofitted. For the retrofitted vehicle, once we need to go through the AIS 123 part 3. It defines what to do and what are the procedures to be followed. So our target is to have the landing price is around 1.5 lakhs per kit. So this is the target because of the battery. Battery is not mass production in India right now. Mostly it is imported, and certain companies are manufacturing in India with Indian technologies. Once the battery cost is reduced very much, then the cost of the kit will get reduced. At the same time, during such retrofitting and these technical things, the technicians and the fitter needs to be trained for how to fit, how to do the repairing and then maintenance work. Those training can be conducted at regional MSME centers, tying up and having MOU and understanding, and we can utilize their existing infrastructure also for the subsystem fabrication and the other things. So definitely we can go along with the MSME for the human resource training and the imparting the subsystem level the training for handling repairing, fitting, and all those things. And the test, we have many test facilities for the new vehicle as well as the retrofitted. And so these test equipments are required to generate the scientific data for analysis and for improvement. And this is our vehicle testing laboratory, where vehicle is mounted on the computer control roller that we call is the chassis dynamometer. Then the vehicle is tested in the laboratory. Then the road conditions are simulated inside the laboratory. Also, our division is also training courses every year. So even now, we are some transport officials are in our campus. We are imparting training to them and sharing the latest the policies, then latest update from the ministry, then and about the latest technology. So this is one part where we can collaborate even with the MSME centers and the training part for the technicians and the fitters. And with this, I conclude my presentation. Thank you very much for your kind attention and your patience. If anybody has any question, and the forum is open to you. Over to you, madam. Thank you very much.
Thank you, sir, for your nice presentation. May I ask now CIDT Hyderabad team to comment? Otherwise, any of the industry partner?
Yeah, this is Sahesh from T-Works. Can you hear me?
Yes, sir, please.
Yeah. So actually, sir, we are looking forward to like take this like technologies which are in the universities and making it ready for market-ready products. We have some industry partners who have an interest in adopting these new technologies. But for this, I think it's better because we are also based out of Hyderabad. I think it's better we meet in person and discuss the details of the like level of the technology that you are at and what are the exact requirements. I've seen in the presentation, but I would love to discuss it further and then see if our requirements are met and take it forward from there.
So definitely we will facilitate the visit for better understanding of the technology.
Yes, sir.
That definitely will facilitate. We will plan it maybe in as per your requirement in coming weeks.
Yes, actually, we are in the middle of writing a proposal for Minister of Heavy Industries, and the deadline is on the 5th of December. So if we can do it in the next 2 or 3 days, then it will be wonderful. We can actually understand better requirements from each other, and also the IPR and technology transfer, and what are the timelines that the like inventor is looking forward to take it to the market.
Sure, sir. In next 2 to 3 weeks, sorry, in next 2 to 3 days, I will come to you after this meeting.
Okay, sir. I'm dropping my number.
Yes,
And,
yes.
I can be contacted on that, and you can also share your number so that we can, keep a track of it.
Yes. I already shared it on chat box.
Yes, sir. I'm just sharing it again. What is your number, sir? This is 94301078.
Yes.
Okay, I'll share your number, sir, and we'll get back to you as just after this meeting. Let's
Sure,
connect.
definitely.
Yes, sir.
And is there any industry from the Hyderabad-based areas? I could see many partners in the participants that Vagdevi Incubation, Teja, Eeva, then Sunita Prasad Ji, Srinivas, then Mirza. Okay, if there is no specific comment, I think we can move to the next presentation. Okay. Santosh Kumar from IMT, are you there in the meeting?
Sir, I am in meeting. Can I already over? Everybody presented?
If you want to present now.
Just after 10 minutes, can I present?
Okay, okay, no issue, sir. We will go to next presenter. After that, we will
Okay,
provide.
I'll present last. How many presenters is there?
Now it's done for the Dr. Mantu Bhuyan from NIST Jorhat. Thereafter, you have the chance to present.
Okay, okay, thank you.
Dr. Mantu Bhuyanji from CSIR NIST Jorhat Lab.
Am I audible?
Yes, yes, sir, you are audible. You just please upload into your presentation.
Okay, okay.
This is a low cost honeybee box. Please upload your presentation.
Yes, yes, yes. I am uploading.
Yeah, please make it slideshow mode.
Is it visible?
Yeah, we can see the presentation, but please make it slideshow mode.
It is not happening.
You can just click that all glass symbol at bottom.
I have already clicked because in my screen it is in slide.
Okay. Then you may please go ahead with the presentation.
Okay. So thank you because I was quite busy. Probably you know that today parliamentary committee visited. I just come.
Your slide is at last, I think. Last slide.
Yeah.
Okay.
Not last slide. The first slide. So
no, we could see your last slide. Thanks slide. We can't see your first slide.
it is not rotating, na? Slides are moving.
It's not moving. Let me take control from my end.
Okay.
I will just move the slides.
Okay.
From here also, you can't move your slides.
I
think
have already
you
given.
You shared your screen.
Yeah, I have given permission to you.
Slides are not moving.
It is moving here.
But can you please reshare from your end? Just unshare and then share it again. While sharing, you just click on the screen share.
Is it now visible?
Oh, it's not yet. We can see the slides, but make it slideshow mode. From beginning. Can you please move the slide?
Yeah, I am moving. Not moving, no?
Slides are not moving, that we can't see. You can present like this. Currently you are at first slide. Now it's a second slide. We can see that.
Okay, this is visible.
Third slide, but it's not visible to read. Kind of convenient. But that you need to make a slideshow mode. At the right bottom, you can just click on the all glass symbol.
When I put this, then moving is not done here.
Then you please do one thing, sir. You can send me slides on my WhatsApp.
Okay.
You just click the all glass symbol at the right bottom.
Hello.
I will share it on my WhatsApp.
या आपको भेज दिया स्लाइड आपको भेज दिया.
Okay. Let me check. I haven't received it. Did you send on my WhatsApp or email?
WhatsApp.
It. Good.
Didi, Ignash. What is presentation to slide board for just?
Okay, I am sharing from my end. I will just move the slides. You have to explain.
Yeah, please.
Yes, sir. Please go ahead with your presentation.
Okay,
This is
okay.
first,
Thank you.
first slide.
Thank you. So good afternoon to all. So we have developed one low-cost honeybee box from the sustainable material. Then if we see the history of honeybee box, there is a very interesting history. For scientific beekeeping, honeybee box is required. But this box is generally prepared by several materials, traditionally from different parts of the world. And in Northeast also several traditional boxes are there, but these are not scientific. If we see the global aspect, generally wood are extensively used for honeybee box. But problem what we are thinking with the wooden box is that it is made with wood. But if we see wood is a very precious environmental resources, and the requirement of honeybee box in India is too much as per 2018 report. If we see, then in that case we have to sacrifice lot of trees for making the honeybee boxes, because a normal bee box of Apis mellifera need around 1 kb of wood, which demand large quantity of wood, and also is a very cost because wooden bee box in Assam it is around 2,200 per boxes to 2,300, and it needs some special expertise to prepare it, because general public they cannot prepare it. It needs some skill to prepare the bee box. Although in India we know the different measurement of honeybee boxes like A type, B type, but it needs some skill to prepare these boxes. That's why we thought for some innovation in regard of low cost honeybee boxes. Yeah, this slide. So this is a low cost BB boxes, and we completely, no, this previous slide, we completely removed the use of wood. Previous slide. Previous slide. Previous. Then again, previous one. Yes. So we completely removed the use of wood in these bee boxes, and whatever material we use, and it is quite environment friendly, and it is basically bamboo base. Base is bamboo, and it ultimately help for sustainable beekeeping practices. The bee boxes is easy to prepare because whatever measurement we have taken, it is as per Indian standard. We have not sensed any measurement for Apis cerana or Apis mellifera. We just substitute the material that instead of wood we use other material. And as per our past experience and research, these new honeybee boxes also completely maintain the temperature inside because temperature and humidity is very crucial inside the bee boxes for honeybee, because all we know that honeybee is an insect which is a poikilothermic animal, so temperature is very essential. And irrespective to seasonal variation, it maintain the temperature around 32 to 33 degrees Celsius, and it gives somewhat better performance than the conventional bee boxes. Next. So these you could see some of the bee boxes. The box we use to rear the honeybee, Apis cerana, because Apis cerana is very much prevalent in Northeast, and we observe the behavior of the honeybee, because this is very important. Probably you heard that around 30–40% honeybee, even colony bees now disappear from the beehive. So we completely observe the behavior, and behavior is very clear, very good, because we got a very good brood growth, brood health, cell growth, weight of the bee colonies, and it is very good. And we compared it to the conventional bee boxes, and it provides complete aeration, temperature, and comfortability, which is very much requirement from the honeybee. So these are our new bee boxes we prepared, and if you see, these are the commercially we already transferred to 4 parties. Basically NGOs and self-help group, and some of the photograph I have shown here to photograph. These are they prepare themselves and distributed to the farmers for rearing honeybee. And it is one advantage is that it is very much easy to prepare. You do not need any industrial scale concentrated unit of production, because if we teach the farmers, they can prepare themselves for their own. Next. So these are some of the photograph I have seen. I have shown you. These are already transferred to different NGOs, and this is another these bee boxes we are seeing. The colony, you could see here how facilitating the colony growth is there. Next. So these honeybee boxes was actually inaugurated by our former Director General Sir on 2021 October, and he formally inaugurated this honeybee boxes. You could see here in our farm we maintain several such bee boxes along with honeybee colonies. Next. So this is in briefly, this is the brief one. I like to inform about the new honeybee boxes, and we are now preparing these Apis mellifera bee boxes, which we are like to send to Lucknow to CSIR and BRI for some CSIR floriculture mission project, and it is prepared by one entrepreneur in our facility under our supervision. And another two party, one is from Chennai and one is from Assam, has already applied for getting this technology, new technology for them. So briefly, this is one, but I am open for any question if you have.
Thank you, Dr. Mantu sir. Now floor is open for discussion. Any questions from CIDT Hyderabad team and the industries? If there is no comments from the industries or the CIDT Hyderabad team, we can move to the next presentation. Dr. Santosh Kumar Behra, are you there in the meeting?
Yes, sir. Yes, sir.
You can please upload your presentation. I will just share from my end. Please make it slideshow mode.
Now visible? Hello.
You can, yes. Please go ahead, sir.
Good afternoon. I am going to speak about export iron pellet technology. This is the automatic process control system for pelletization disc in steel industry. Myself, Dr. Santosh Kumar Behra. With me, Dr. Devi Prasad Das is my head is available here. Before going to technology, I'll tell about what is the pelletization, what is the importance. As per steel policy of India, pelletization has to be given priority. Pelletization is a process of making bars, that is called pellet, from iron fines for blast furnace. There's the increased demand of steel, but lack of high-grade lumpy ores. We are getting fines and low-grade iron ores. The pellets formed by rotating disc shift to desired size. The desired size is 8 to 16 mm, and less than 8, more than 60 is undesired. You have to recycle once again. That is we call less than 8 we call undersize, and greater than 16 mm we called oversize. And our objective is to increase the desired size range, that is 8 to 16 mm, maybe 90%, and we have to reduce the recycle load. It is a very complex process, and the size depends on ore type, moisture content, binder type, RPM means rotation of disc, and TPH, that is feed rate, and angle of inclination of disc. So how it is controlled now? One human supervisor is standing, and there are 6 discs in one plant, and he's watching the pellet size, and he's observing by his naked eye whether the pellet size is the desired size, or whether the size is increasing or decreasing. Then he's telling to control room person to change the RPM and TPH. This leads a lot of human error and difficult to take decision on multiple discs. This is the pellet plant process. One disc is there, and iron fine faded by conveyor belt on the top of the disc. And there is a binder and a water spray, that is water by water nozzle, and due to rotation, and the pellets are formed, and the pellets are falling to the conveyor belt. And at the discharge end, we are capturing the image. The application is the monitoring and control of pellet disc used in steel production. We named as the technical name is export iron pellet. Status already we filed patent and already granted. Iron ore pellet manufacturing industry, generally steel industry, will use this technology. And already you told, pellets and discs are controlled by a human operator, and operator watches the disc to visually estimate the size of green pellets and control the disc parameter manually. They work in 3 shifts in very dusty and noisy area. Pellets are of desired size, that is 8 to 16 mm, is not always possible to produce through manual control. Our approach is camera-based vision system for real-time size analysis, and rule-based export control system to control the disc parameter, that is RPS, the RPM and TPH, and we are controlling through DCS system of plant. This is a semi-automatic control system which will control RPM and metal feed rate. Benefit of this technology to industry is auto control helps in eliminating human errors, increases production, and also avoid exposure to human operator from dusty and noisy environment at plant site. Already filed 2 patents, one for monitoring system, another is for control system. You can see this pellet disc rotating some certain speed, and we have installed a camera at the discharge end and illumination system, and continuously we are capturing the images, and we are doing image processing, and we are telling the site distribution, that is less than 8, 8 to 10, 10 to 12, 12 to 14, 14 to 16, greater than 16, in terms of percentage, in terms of weight percentage. And this camera is connected to this local monitoring system that is called iron pellet. This iron pellet is controlled, this connect to control room through OPC communication through fiber optics, and there is a controller is available in the control room, and that controller is connected to plant DCS system. The right side, the GUI of our control systems. This is the architecture of our control system. Here you can see a camera is there to capture the continuous image. The camera is connected to monitoring system, that is the iron pellet system. One PC is there, or embedded hardware will be there, and which will tell the site distribution in different size range. And this iron pellet system, this monitoring system is connected to export iron pellet system through OPC communication. And this export iron pellet control system take a size information from iron pellet, as well as RPM and TPH value of disc from plant DCS system. You can see here right side is the plant DCS system, which is giving the sensor value of RPM and TPH to the export iron pellet, and export iron pellet is giving the command to DCS system to change RPM or TPH as per requirement. This is the simple PID control cannot work here. That's why we developed export iron pellet system. Here only one bottleneck is there. Plant DCS system is very old technology, and we have to interface our export iron pellet system to plant DCS. We are using OPC UA communication, and plant is having OPC DA communication. We have to synchronize these two things properly, and we are doing that one. Then this already we have installed at the JSW Steel Vijayanagar. They are using this technology. Plants are running in auto mode. You can see here there is a disc, and there is a camera, and this is a local monitoring system, iron pellet system. This is a server, And here the GUI of ion pellet system, and this is the GUI of our control system, that is the export ion pellet system. And the major plant equipment and the machinery required for this system is one camera with enclosure and a computing platform, that is PC, with embedded software. We'll use two numbers because one will use in near the disk, another is in the control room, and two display system, and NI Labor runtime software, NI Vision Acquisition runtime, NI OPC UA toolkit for deployment, bidirectional communication setup with existing plant DC system, communication system, accessory for mounting and installation. And advantages: multi-input and multi-output controller for controlling the parameter of iron or disc palletizer, expert knowledge-driven rule-based controller for controlling the rotational speed and feed rate of the palletizer disc, bidirectional communication and integration with the existing DCS, option for switching from auto control mode to manual control mode in the DCS. We are having two options. When there is a problem, we can switch over to manual control mode. It can be installed in any existing and a new pelletization plant. It can be customized for similar use in other production plants like wood, medicine, and food industries. Already we transferred the technology to SBNT Infotech Private Limited. Already that duration is already over in February 2024. Technology commercialized at JSW Steel Pellet Plant 1, Bellary, JSW Steel Pellet Plant 2, BMMEs Limited, Hospet. And we are competing with the Autotech Metso company. Worldwide, only one company is having such type of product, that is the Autotech Metso, then Finland-based company. And due to our technology, he reduced the price, but still we are becoming L1. And around 4.5 crores already we got order for this technology. And there is a lot of demand in this technology. There are a lot of in India, only BMM Ispat and JSW Steel are using this technology, and a lot of like Tata Steel and SR, BRP, a lot of pelletization plants are there. They can use this technology, even if you can use this technology for foreign. Thank you.
Thank you very much, sir, for your presentation. Now, floor is open for any kind of comments or discussion required. MSME Hyderabad team, CIDT Hyderabad. Gulshan Bish, sir, are you there? From CIDT Hyderabad.
Yes, sir. Sir, I'm here.
Yes, sir. We finished with the presentation, sir.
Yes, yes. The recent one was interesting. Ion pellet. That is interesting. I think many MSME industry, this technology will be very useful for them.
Okay.
If I can get a short note on this one, I can circulate it to all the MSMEs, those who are not present over here.
Yes, sir. Definitely, we will send you the presentation copies along with the short write-up about the technology.
Yes, sir. That will be great.
That would be better for understanding at any level. That we will be sharing with all the participants, even with both the teams, Agra and Hyderabad team. Apart from that, anyone wants to say anything? Maybe from our industry friends? Industry friends have joined the meeting, but they are not speaking. I could see more than 10, 15, around 15 participants from the industry side, majorly from the CIDT Hyderabad base. Okay, what we can do, since we are finished with our presentations, I thank you all CSIR scientists who presented here. And I request for your presentation copies, you may please send it on my WhatsApp or my email. That would be fine. And I must thank you, my industry friends who joined from different places and they have shown their interest in our technologies. Anyway, we will be sharing the presentation copies along with the technology brief details. And you can come to us whatever the requirement on these technologies. Otherwise, you may please let us know the what are the other areas where you have interest in taking up CSIR technologies. We can share our technology compendiums. We have the many technologies in area wise. It was classified both food sector, then metal mineral sector, then waste to wealth sector, then e-waste recycling and e-waste management sector. Like that, we operate from different kinds of the SNT domains. CSIR operates in that way. So we can share the sector-wise technologies list to the participants as per their requirement. And we would like to hear again back from you people. Thank you very much, sir, and thank you very much all the participants. Thank you all.
Thank you so much, sir. Thank you.
Thank you. Thank you.
Thank you. Thank you.